Hello guys, welcome back to Maison African Motives, still on our revisions for mathematics grade 10. In this class, we shall be actually focusing on the expansion of the brackets that we are having dealing with our algebraic expressions. So algebraic expressions, we shall be actually focusing on the multiplication of the algebraic expressions. But before we focus on these questions, I just want you to get back here and have a basic understanding of what exactly we are referring to on these algebraic expressions. Remember, on your algebraic expression, what is important is to understand that you've got different types of expressions that you are going to apply in your algebra. There are different types of expressions that you can have. One, we've got an expression with one term. That expression that has got one term, for example, we can have it as 6x squared, or maybe it's 3x to the exponent of 3, whatever term that you can have, as long it's a single term like this, that is one term only, we are going to refer to that one as a monomial. So that one is a monomial expression which has got one term. Then we've got an expression that is the sum of two terms. So you can have two terms. That is, for an example, we are adding 3x plus 1. Maybe it's 10x squared plus 3 like this. We are now having what we refer to as a binomial expression, where we have got the sum of two terms. Binomial, the only one term that is given, it's a monomial. Then we have got an expression that is a sum of three terms. So when you have got three terms being combined together, that one is called a trinomial. All right. So that is the most important terms that we are going to actually be focusing with, and also on your expressions that you are going to have. Remember, we are referring to an expression in this case. So if I am given an expression, for example, it's a 7x plus 3. I'm given an expression in this case. If you are to check here, this we are referring to as a variable part, the part that has got x. So x is the variable in this case. All right, we are referring to this as a variable. So that is the symbol x is often used to represent the variable in algebraic expression, but other letter symbols may be used. So we can use k in this case, maybe it's 7k plus 3. That means the variable is the letter that is going to be applied. So our variable there is k, all right? Then we have got the number that is multiplying the variable, this one. It is referred to as the coefficient. So this one is the coefficient of x. So meaning to say, if I am given, for example, what we have here, this is 100 x to the exponent of 3 plus 45x to the exponent of 2 minus 50x. So if I am to consider this, I'm going to say that this 100 here is the coefficient of x cubed, x to the exponent of 3. So 100 x to the exponent of 3. This 100 is the coefficient. Remember, the number that is multiplying x, the letter that you're given. So in this case, we are saying it is the coefficient. All right. So 100 is the coefficient in this case of what? Of x cubed. So this is the coefficient of x cubed, not of x. The coefficient of x, you have to consider where there is x here, meaning to say the coefficient of x, the coefficient of x in this case is going to be given as what? As negative 50. So that is negative 50 in this case. That is the coefficient of x. If we are referring to the coefficient of x squared, that will be plus 45. All right, why am I talking, or why am I actually referring about these coefficients like this is a major part of our multiplication? This is exactly a major part of our multiplication, because whenever you are working with a multiplication, let's consider, for an example, I just have a term outside of the bracket. Maybe it's just a single number that I'm having, which is 3. outside of the bracket. Let's say I'm given to expand this into x plus 3. All right, so the question will be for you to expand, to remove the brackets that you are given. So it's a multiplication that is going to happen. So if you are to take a single term outside of the bracket, you are going to multiply everything inside the bracket by that term that you have, or the number that you have outside of the bracket, which is, in this case, we are referring to 3. So 3 is going to multiply x, and 3 is going to also multiply this 3. So in our simplification, we are going to see that this is going to give us 3 times x, which is going to be 3x. So what is happening is that you are simply having a 1. The coefficient of x here, there is a 1 which is there. So if the number is not given, it means there is a 1. It's not a 0. No, it's a 1. So meaning to say the 3 is simply multiplying the coefficient, just like the part that I was explaining, to say 1 is the coefficient of x. So the 3 is going to multiply 1. The 3 is going to multiply 3. So it can only multiply a number that is outside, or the number that is multiplying x. So that's 3 times 1, which is going to be 3x, because we have got an x that we have here. All right, then we've got 3 and 3. If we multiply 3 times 3, that is going to give us a positive 9. So that means we have expanded our bracket. We are just given a single term, a single number outside of the bracket, but it can be a condition that we have got x outside of the bracket. It can also happen like that. Maybe it was given as 3x into 7x minus 1 like this, and we are supposed to expand this bracket. If you are to consider on this case now, you are going to see that the 3x that we have, it is going to multiply the same way. It is going to multiply the first term, and it is also going to multiply the second term. But as we are multiplying, I want you to see properly, this is 3x, this is 7x that you are multiplying together. So we are having a condition of 3x by 7x like this. So meaning you're going to multiply the numbers together, which is the 3 and the 7, just like the same way that we had the 3 and the 1 that gave us 3. So here we've got the two numbers that we have, which is the 3 and the 7. So if we multiply this, this is going to be positive 21. Then you have got x and x that we have. So if you multiply a condition of x and x, that is going to give you x to the exponent of 2. All right, that is a condition that you actually consider from your exponents. Remember, if the exponent is not given, it means that is to the exponent of 1. Multiplied to the exponent, again, x to the exponent of 1. So whenever you are multiplying a condition like this, when the bases are the same, you add the exponents. That's 1 plus 1, which is going to give us a 2, right? So that's why we see here, we've got x squared. So that means we are going to obtain 21x squared at the end, all right? So that will be positive 21x squared. So you're going to draw the same thing on your simplification, just like the previous part that you had, but this time you are multiplying 3x and minus 1. So it's just like what we had in this case on the previous part. So what is just going to happen, you're going to just multiply the numbers together. That is 3 times minus 1, which is minus 3, but we've got x there, all right? So on this part, you must consider that we have got x and we've got x. So we have to multiply x and x, but here we do not have x. We just multiply minus 1 to this 3. It gives us a negative 3, all right? So that is how you are going to be using your expansion. But if you are to consider, it can be on a condition still on your expansion. It can be a condition now when you have a bracket. Those are the typical questions that we see. So I'm just going to have an introduction that we talk about those questions that we are given there. So if I'm to have a condition where I'm given two brackets, consider that I'm having x plus 3, which is being multiplied to x plus 2, or maybe I can have it on a condition like maybe I'm given x plus 2, in this case, into the bracket of x squared plus 2x plus 1 like this. So I want you to be very, very careful, because the expansion of brackets is not on two brackets like this. It's not only two brackets. It can be also 3 brackets. You can also have another bracket here. The idea is that once you expand the two brackets, you are going to have an expression of this, which is called a quadratic expression. We are going to have that, which is the one that we refer to as a trinomial, the one that just got 3 terms. So I'm giving this as an example so that once you have that type of equation, you will know how to expand. So what is important is that how do I expand these brackets? There's so many methods that you can consider. Someone can consider x to multiply every of the bracket. You separate that, 3 multiplies every of the other bracket, which is actually fine. So I'm going to consider the traditional method, that is starting from the beginning, then we consider it in a shorter way. All right, we could have just said, because this bracket here is multiplying the second bracket, or the second bracket is multiplying the first bracket. It's vice versa, just like 2 times 3 and 3 times 2. It's just one and the same thing. One and the same thing. So it's either is this bracket that is multiplying the second, or the second multiplying the first. So on a condition like that, what it means is that everything in this bracket must multiply everything in the second bracket. So that means the x here must multiply everything that we have in this bracket. So it's going to be x into the bracket of x plus 2. The same thing with this plus 3 that we see here. It must multiply everything in this bracket as it is. So it's a plus 3 into the bracket of x plus 2. So I said I'm going to explain the shorter method way later on. But this is like actually what you're supposed to do. 3 has to multiply everything in this bracket. X has to multiply everything. Then 3 has to multiply everything in this bracket. So this is the condition that we have here. X multiplying everything in the bracket, then 3 multiplying everything in the second bracket, which could have been another way out. X multiplying everything in this bracket, all right? X multiplying everything in this bracket, and also plus 2 multiplying everything in this bracket of x plus 3. Still, you are going to obtain the same answer as long what you are writing there or what you're presenting is correct. All right. So in this case, we multiplied the first bracket to the second bracket. All right. So meaning to say here, I'm going to have x times x, which is going to be x squared. Remember, we talked about that when x and x multiplies each other, we are going to have s squared. We've got 1 and we've got 1 here. So we add, all right, plus we multiply x times 2. So this time x is going to multiply these 2, which is going to give us 2x. We are done with this bracket. X has multiplied everything in this bracket. We move on to plus 3. It multiplies this x, so it is going to be plus 3x. So 3 is multiplying x, it's a plus and a plus, so it will be plus 3x. Then 3 times 2, which is going to be a plus 6. So if I'm to consider this, I'm going to see that I've got like terms in this case. So I've got the addition of like terms. There is x and x here, and having the same exponent to the exponent of 1 to the exponent of 1. So that means these are like terms. It is not a like term to x squared because this is to the exponent of 2. So it cannot be added to x, which is not raised to the exponent of 2. So we are going to consider this part only. This is the only part of the like terms. So that means we are going to add 2 plus 3. We are simply adding the numbers here, 2 and 3, which is going to give us 5, but we've got x there. Take note, you are adding, you are not multiplying, so you're not going to multiply this at x and x. Your answer is going to remain with x. You just add the coefficients of what? Of x. All right, then 6 is a constant. We do not have anything that is affecting this 6. So that means we are going to remain with this as our final answer from this expression. All right, like I said, this is the longer way that we could have taken, where I have to show the expansion of the brackets. But the shorter way, as we can see, that x is going to multiply everything in this bracket. This 3 is going to also multiply everything in this bracket. Why can't I do it by side, by just looking into the question and answer it direct? All right, let us consider that x is going to multiply this part, and also it is going to multiply this part. This is what we see. So let us multiply x times x, which is going to be x squared. Then x times this 2, which is going to be 2x. I'm done on this part. I know that x has to multiply everything. So make sure that x multiplies everything. You are done with x. You move on to this number plus 3. This one, it has to multiply also everything in this bracket. So it's plus 3 is going to multiply x, plus 3 is going to multiply 2. So it must multiply everything. So that means we have got 3 times 2, the plus here, 3 times x. So that is going to be 3x, because we've got 3 and 1 here, 3 times 1, which is going to be 3x. Then 3 times 2, which is going to be a positive 6. It's a, as you can see here, it's positive, positive. So that will be a positive 6. Collect your like terms. As we can see, we've got x and x here in the middle part here. There is a part with x and also x. We can add the coefficients of x, which is 2 plus 3, that is 5. So that is going to give us 5x plus 6. As you can see, we are obtaining the same answer just like this one. But here we had to consider it direct without showing the part that I'm going to expand. You just know that x must multiply everything in the other bracket. All right, it helps if you understand this. If they are now 3 brackets and you have this in mind, it is not going to be difficult for you to expand such type if you have got a question like this, because you simply know that the first term must multiply everything in the other bracket. So that is the same scenario that we have here. The x has to multiply this x squared. It has to multiply this 2x. It has to multiply this number 1. Once you understand this, it's not going to be a challenge. Even if you've got 3 terms, it is not going to be a challenge for you. All right, let us multiply together. All right, so this is going to give us, if we multiply here, all right, so consider that, remember I said x is going to multiply with x squared. So this time we've got x and we've got x squared like this. This is to the exponent of 1. If the exponent is not given, it means we've got an exponent of 1. So once the bases are the same, I have to add the exponents when multiplying. So that means I'm going to add these two, 1 plus 2, which is 3. So that is going to give us x to the exponent of 3. So this part and this part gives us x to the exponent of 3. All right, I'm done with this part. I move on to x and 2x. So if I multiply x into x, I'm going to have plus, here there's a 1, so it's 1 times 2, which is 2, and x times x. Remember, we said it gives us x squared. 1 plus 1, which is a 2. All right, we move on to 1x times 1 at the end. So this is 1 times 1, which is going to be 1x. So it is going to give us 1x, but 1x can be written as what? As x. Remember, if the 1 is not written, I have to put a 1 like this on the simplification, meaning to say on my final answer, if I'm having my answer as 1x, I'm just going to write it as what? As x. So 1x is same as x. It's different from 2x. 2x is just 2x. It cannot change. The moment you write it as 1 as x, it will be wrong, all right? But for 1x, you can just leave the 1 like that, right? So we are done with the x. So it is the same thing with this 2. It has to multiply the positive 2. It must multiply everything in the second bracket. So that is plus 2 has to multiply x, plus 2 has to multiply 2x, plus 2 has to multiply plus 1. So we must multiply everything in the second bracket by 2, just like what x did. So it's 2 times x, the positive there. 2 times x squared, this is same as 1. So 2 times 1, it will be 2x squared. All right, 2 and 2x, that is 2 times 2, which is going to give us 4x. Then 2 and 1 here, 2 times 1, which is going to give us a positive 2. So at this stage, you can now collect your like terms, considering that we have got 2x squared here, and we also have 2x squared there. So there is an exponent of 2 there. So we are going to add these two together. So that means we've got x cubed, all right, 2x squared plus 2x squared, right? Remember, just have to add 2 plus 2, which is 4. Add the coefficients, and the x squared remains as it is. All right, the same thing, we've got x here, which is 1x, and we also have 4x. So this is same as 1x. So we are going to add 1 plus 4, which is 5. So that is going to give us 5x in this case. Then we are left with plus 2 at the end. Remember here, there is a plus 2, a constant. So we're just left with a plus 2. Remember, in your algebra, guys, from your mathematics grade 9, this cannot be simplified. Whether we see that there is x, there is x, there is x there. They are of different powers or different exponents. This is 3, this is 2, this is 1. So these cannot be added. You can only add the ones that are having the same exponent, just like what we did on these two, because they have got the same exponent, which is 2. And also on this part of x, these are like terms. But on these ones, they are no longer like terms because of what? The different exponents that we have. So we cannot add these numbers. We just have to leave them like that. So this is the simplification that we are going to be actually talking about in this class so that you properly understand what exactly is it that you're going to be referring to on your expansion. So like I said previously about our terms, that you just need to know your terms, the trinomial having 3, the binomial having 2 terms, the monomial having only 1 term. So with this, let us try to answer these typical questions that we have here. All right. So I'm just going to answer 1 or 2 questions, then I give you others for you to do as an exercise so that we can come back again to revise those questions together. All right, so this is a simple exercise that you're given. This is on the multiplying of expressions. So the first part that you're given is to square the binomial 3x minus 4. All right, binomial. Why binomial? If we consider we've got 1, 2 terms that are being given. So that's binomial. All right, so they are saying we are supposed to square. All right, let's consider the word square. To square a number or to square a term or to square a bracket. That is to raise that term or bracket or that number to the exponent of 2. That is to square. If it is to square 2, it means 2 to the exponent of 2. If it is to square 3, it means 3 to the exponent of 2. To square 4, it means 4 to the exponent of 2. So to square, that is to raise a number to the exponent of 2 or an expression, whatever that you're given. So here we are given to square this binomial here. All right, so let us square the binomial, which is 3x minus 4 like this. So they are saying we are supposed to square it. All right. But we can't just square this binomial like this, then leave it like that. No, we have to expand. What does it really mean here? Just like in a normal simplification, 9 to the exponent of 2 means 9 times 9. So if I'm given 3x minus 4 to the exponent of 2, what does it mean? It means I've got 2 brackets that I have to consider of 3x minus 4, another bracket of 3x minus 4 like this. I've got 2 brackets. Not to say I'm going to multiply this as 3x squared minus 4 squared like this. This is totally wrong. It is totally wrong. You cannot expand that way. It means you've got 2 brackets that you are supposed to expand. So as you can see, we are back to that expansion that we were talking about previously. Remember what I've been talking about. If you're given this type, you have to expand. The first term must multiply everything in the second bracket. So we are going to multiply 3x times 3x. So 3 times 3, that is going to be 9x squared. X and x is x squared. All right, 3x and minus 4, that is 3 times minus 4, that is minus 12x. So remember, we've got x there. All right, we are done with positive 3x. We're done. We move on to negative 4. It has to multiply here, and also it has to multiply this term. So this is negative 4 times 3x. So negative 4 times 3, which is negative 12, all right? So it's negative 12x. If not, you can just use your calculator on your simplification. If you are not sure about your multiplication, just try by all means to make sure that you use your calculator. Negative 4 like this times positive 3, which is going to give us what? Negative 12, but we've got x there, all right? We do the same thing, negative 4 versus negative 4, which is going to give us positive 16, or you can multiply negative 4 times negative 4 like this. That will be a positive 16. So at the end, this one is going to give us a positive 16. So that is how you can simplify whatever that you are given in this case. So at this stage, remember I said you have to consider your like terms. So you have to consider collecting your like terms. We've got x and x here. So these are like terms. So meaning to say at the end, I'm going to obtain 9x squared minus 12x minus 12x. That is minus 12 minus 12. It gives us negative 24. All right. Or even here on our calculator, you can simplify. That is negative 12 minus 12 like this, which is going to give us negative 24. So you've got negative 24x plus 16. All right. So that is how you can simplify that. And as you can see at the end, we've got an expression with the 3 terms, 1, 2, 3. So this is a trinomial. So we are now referring to a trinomial that we have at the end from expansion of a what? Of a binomial. We expanded or we had to square this binomial, and the answer that you're obtaining is a trinomial. All right. So that is how you're supposed to work with this part. So as you can see, it is the same situation or the same condition as the B part. There where we have given expand 2x minus 5 into 2x plus 1. All right. So this is into 2x plus 1 like this. So it is the same situation or the same scenario that you are given to expand, whereby the first bracket has to expand or has to multiply the second bracket in this case, all right? The term 2x and 2x here, the same 2x and 1. So meaning to say we are going to obtain 2x and 2x, 2 times 2, which is 4x times x, remember, that's x squared. All right, we've got 1 here, 1 plus 1, which is 2. We are done. We move on to 2x and plus 1. So 1 times any number, guys, as you know, it remains as it is. We just multiply 1 times 2, which is 2, and we remain with x. So we are done with 2x. It has multiplied everything. Let us move on to the other number, which is minus 5. So it's minus 5 into this bracket, minus 5 into this part. All right. So that means we've got minus 5 times 2, minus 5 times 2, that is minus 10, but we've got x on this part. All right, then we've got minus 5 and plus 1. So if we multiply minus 5 times 1, that is a minus 5. And on this part, we are going to collect our like terms. So that is, we're going to have 4x squared, and the like terms here, we've got 2x and 10x. So if I subtract 2 minus 10, that is minus 8. So we are going to obtain minus 8x minus 5. All right, so that is how we can simply expand whatever type of an expression that you might be given in your simplification. So it is the same thing that we are given expand on question 3. We are now given expand. All right, so let us see, like I explained before, that it is just one and the same thing, 2a plus b into the bracket. So this is a binomial which is expanding a trinomial with 3 terms, 1, 2, 3. Here I've got 2 terms, so we've got a condition of a binomial expanding a trinomial of 4a squared minus 2ab plus b squared. All right, so this is a nice question. Now we do not have the x like what we had before, but the idea there is the same. How you work out your questions is the same, whether we've got x or we do not have x. How you work out your questions is the same. So what you're going to consider in this case is that, all right, I'm given 2a plus b. All right, so the 2a plus b has to expand everything in the second bracket like I explained before. If you understand this, even if you are given 3 terms like this, it won't be a challenge to you. So you just have to multiply 2a, has to multiply this term, all right? 2a has to multiply this term, 2a also has to multiply this term, each and every term in the second bracket. All right, so that means here we are having a multiplication. All right, let us multiply. It's 2a times 4a squared. So that is 2a like this times 4a squared. So remember, we are back to the addition because we are considering, in this case, a condition of having the same basis. So the numbers you're just going to multiply 2 times 4, which is 8. Then on the basis, we have to add on this part of multiplying the same basis. In this case, you have to add your exponent. So it's 1 plus 2, which is 3. So that will be 8a to the exponent of 3. So if I multiply this term and this term, I obtain 8a to the exponent of 3. All right, I move on to this part here. So it's 2a versus minus 2ab. All right, so as we can see, we are already having a negative, but let us just multiply this. So it's 2a, all right, which is multiplying minus 2ab like this. So if you are to consider this is a positive, so we've got a positive and a negative, which is going to give us a negative 4 in this case. Then consider that we have got a and we also have a. So we're going to multiply a times a, all right? So take note, this minus, guys, is just there. Minus is the number that is affecting 2. As we are multiplying a here times this a. So that is going to give us a squared. This is 1, this is 1. So 1 plus 1, which is going to give us a 2. So that is a squared, and this is a b. All right, we do not have any term that is going to multiply this b that we have. So it is just going to be a b. So meaning to say I'm going to remain with minus 4a squared b like that. I'm done with this 2a and this term. All right, I'm going to move on to this term of 2a and the last term. This time we are now at this term, the last time that we are given. So that means there I have to consider 2a to multiply b squared. That is 2a to multiply b squared. So there's nothing that it's just a combination because here there is a, here there is b. So I just have to multiply 2 and 1, which is just 2 there. So this one is going to be 2a b squared. All right, there's nothing common that we can use to say the bases are the same. So that is the 2a is multiply the first term, second term, third term of this expression. It is multiplied everything. It is the same scenario that we are going to have, or the same situation that we are going to have with the b. So b is going to also multiply this term. It is also going to multiply this term, and it is also going to multiply the last term. And also consider to say, yes, you are multiplying by b, but consider to say the order that you have in the first place. You are supposed to maintain the same order. Like if you start with a followed by b, a followed by b like that, you are also supposed to do the same thing so that you do not confuse yourself when simplifying. So you are supposed to have your answers in this order, a followed by b. All right, so let us multiply the first one. So remember it's b, which is going to multiply 4a. So it's b times 4a, b times 4a squared. So as you can see, we do not have any common terms. So we're just going to write as it is. So that is going to be plus 4a squared. Remember, I said the order now is important because we are supposed to have maybe 4ba squared. But instead, write as 4a squared b. Start with a followed by b. So this will be 4a squared b, so that you do not confuse yourself. You will properly see where you have got like terms. You can properly see, okay, here I've got like terms, or I do not have like terms. So you have to consider that part, all right? You have to consider that part. So that is the multiplication of b. It is multiply this term, all right? We've multiplied, then we consider b to multiply the second term, all right? So we are now b and the second term. So it's b multiplied 2. All right, let us just multiply direct because here you can see that we've talked about this before. So it's a positive and a negative in this case, which is going to be a negative. Then here there's a 1. So if you multiply a positive 1 and negative 2, it'll be a negative that we see. All right, then we've got a. Then if you multiply b and b squared, and b, remember this is b and this is b. So it is going to give us b squared. All right, then the b has to multiply the last term, which is b squared. So b times b squared, for the same base, we're going to add the exponents. That will be b to the exponent of 3, like that. So at the end, you are now supposed to collect the like terms. That is now the idea that I was talking about. So if you write in the order that you understand, like a followed by b, a followed by b, you can properly see where you have like terms and where you do not have like terms. All right. And so this is going to give us 8a to the exponent of, we do not have anything that is to be added to 8a to the exponent of 3. We do not have any term that can be added to this set. We do not have a like term to this. B to the exponent of 3 is not a. So these are totally unlike terms. This is B, this is a. So these two cannot be added. So what you do is that the terms with the higher exponents, which is the exponent of 3 and the exponent of 3, you use those terms to shield up your expression. What do I mean when I'm saying to shield up our expression? We are going to have them at the beginning of the expression and also at the end of our expression, so that they shield up everything inside here. So that is how you are going to have your answer. So this term, you just write it at the end. But as we can see, we've got like terms. How do I see the like terms? I have to check the term a squared and b. All right. So where do I have a squared and b? I've got a squared and b here. This is a, b squared, not a squared. So I have to consider where there is a squared and b squared. So these are the like terms. So if I'm to consider minus 4a squared b squared plus 4a squared b squared, it's minus 4 plus 4, which is a 0. Remember, minus 4 plus 4, that's a 0. So this one is already eliminated. It cancels out. Right? So it's not like always you are going to have these terms canceling out. It's just because of this expression. It's not always. All right? We move on to the other term that we have in this case is this part of a b squared, the part that you've got a b squared. We also have a b squared here. So these are like terms. So if I'm to consider here, I'm having 2a b squared minus 2a b squared. So as you can see, 2 minus 2 again, that's a 0. So meaning to say these two terms, they cancel out. So at the end, I'm going to be left with a b to the exponent of 3, and it has nothing to be added to. We do not have any common term on this. So the answer is just going to be b to the exponent of 3. All right, there is actually a factorization. We shall talk about that when we are talking about when we are referring to factorization in another class. There's a part of a factorization where actually you are supposed to factorize this type of an expression. And if you factorize this type of an expression that we see, we are going to have our answer like this. So here they are actually moving from the factorization that we are used to. All right. Factorize this, it gives, now they want you to expand the brackets and see if you can obtain the same expression that you are supposed to have. The one that you had before you had this bracket, before you factorized, this was the expression. When we factorized, we had got brackets. So expansion, it's removing of brackets. We are now removing the brackets. All right, so that is the part of our expansion, how our questions sometimes might be given as. So all you just need is to make sure that you play around with more questions, do as much questions as you can from your question papers so that you can understand this topic or whatever that you're talking about now. All right, so Now we are given find the products and simplify. All right. So here we have got these two and also these two. And take note, we are subtracting our terms at the end. All right. So let us see how our question is supposed to be like. So there we are given two brackets, the bracket of 2a minus 5b into the bracket of 4a minus 3b. All right. Minus we've got the bracket of a plus 3b into 5a minus 12b like this. Okay. We are asked to find the product, and not only the product, we are also supposed to simplify further. Whatever that you are having at the end, you must simplify. So the condition that you are simply having in this case is that if you are given two brackets like this, okay, we talked about this, expand 2a is to multiply everything, the same thing with the second part, but consider that we've got a subtraction now. So meaning to say whatever that we are going to get here, we are supposed to subtract our terms at the end. But the idea of expanding the brackets is not even changing. We are having the same thing. 2a is to multiply everything in the second bracket. So we are going to multiply 2a times 4a. So it's 2 times 4, which is going to give us 8. Then a and a, it gives us a squared. So 2a times 4a, that is going to be 8a squared. You move on to 2a and minus 3b. So it's 2 times minus 3, which is minus 6 ab in this case, right? You're multiplying 2 and 3. It's a positive, negative, so it will be a negative. All right, we are done with the part of 2a. We move on to negative b, 5b, and 4a. It multiplies everything. Negative 5b and negative 3b, it multiplies everything. So that's negative 5b times a, 4a. So it's negative positive, which is going to be a negative. So the answer actually, we're supposed to have our answer as negative 20. If you multiply negative 5 and 4, that will be negative 20 BA. But consider the way that you've written the first term. It's AB, AB. So for you not to confuse yourself, write this as what? As AB. So it is going to be minus 20 AB in this case, all right? So that you can properly see these are like terms, all right? So you can properly see the like terms that I've got AB, I also have the AB. But it's the same thing, all right? Then I move on to the 5B and the last term. So take note, it's a minus here, it's a minus there. So we're going to consider this as a positive. Negative times negative, that's a positive, right? Then if I multiply these two numbers, I'm going to obtain 15, and b times b, which is b squared. So it will be positive, it's going to be a positive 15 b squared, all right? Then, like I said, we are supposed to subtract there. There's a subtraction that we have. So we are supposed to subtract our terms at the end. So that's a minus. But since we are supposed to subtract and the minus has to affect everything that you're going to have in our simplification. So it's either I'm going to expand the minus this bracket, or I'm going to subtract everything at the end that I'm going to get after expanding, just like what we see here. After expanding, we are going to have this type of an expression. So it is the same scenario that we are going to have, or the same situation. After expanding this, we are going to have this type of a bracket, or this type of an expression. So just like what we had in the previous case, a is going to multiply with 5a and also with minus 12ab. So that means we've got a times 5a in this case, which is 5a squared. So a times 5a, which is 5a squared. Then we move on, a times minus 12. So that's a minus, this is such a 1. So 1 times minus 12, right? Then we've got a, b in this case, a and b, and also maintaining the order a, b, a, b. Right, we are done with the part of A. It is multiplied everything. We do the same thing with the plus 3b. It must multiply everything. So it's plus 3b. It has to multiply 5a plus 3b. It has to multiply minus 12. So that means plus 3b times 5, which is going to be 15, positive times positive. So the answer was supposed to be actually 15ba. But because we have maintained the order of A, B, A, B, A, B throughout, so we are going to just write this as 15AB instead of writing as 15BA. It's one and the same thing, but writing BA and AB at the same time, most of us guys will end up having a confusion on exactly what is happening. You end up having a confusion there. So avoid that, all right? So let us multiply the last part, 3b minus 12b in this case. So it's positive 3 and minus 12, which is minus 36 in this case. So this is going to give us negative 36b and b, which is b squared. So we are going to obtain negative 36b squared. So like I said, if you are doubting your multiplication, just use your calculator to multiply whatever that you have. This is 3 and negative 12. So I can just multiply 3 times negative 12 like this, which is negative 36. But I've got also b and b, which is going to give us what? B squared. So it is the same scenario that you're going to have after multiplying. We can collect our like terms here, which is going to be 8a squared. So here we've got minus 6ab and minus 20ab. These are the like terms that we are going to consider. So that means we've got minus 6 minus 20 in this case. All right, so on our calculator, minus 6 minus 20 like this, that will be minus 26. So we are going to obtain minus 26 AB, and the 15b squared cannot be related to in any term. It's an unlike term to anything, so just write as it is. All right, minus, also simplify here to have a single part, like just try to expand before you use this minus. Yes, you can use the minus at this part, but it's fine. But just expand first. That will be, simplify first inside the bracket. Just collect your like terms because we've got negative 12ab here and 15ab. So these are like terms ab and ab. So from our calculator here, we need the value of negative 12 plus 15. So that's negative 12 plus 15 like this, which is going to be a positive 3. Negative 12 plus 15, that is going to be a positive 3ab like this. All right, minus 36b squared. This one cannot be added to any term from this part. It's an unlike term that we see. So what we are going to do is that after you have expanded, after you've collected your like terms, now you have a single term here, just like what we had. We've got a single term after combining these terms that we have. So what we are going to simply do now is expand everything by the negative, then we can collect our like terms as well. So here there's nothing to be expanded. If we are to expand, we're going to have a bracket like this and put a 1, and that one cannot even affect anything. So this is going to remain as it is, minus 26ab plus 15b squared. So the minus here is going to multiply everything in this bracket. Every term is going to be affected by a minus. Remember, this here simply means we've got minus 1. So it's minus 1 times 5, which is minus 5a squared. Minus 1 times 5a squared, minus 1 and plus the minus there. So we are simply changing the negative positive to negative. So it's minus 3ab. Then we've got minus and a minus there, which is going to be a positive. So we have got a positive 36 b squared. All right, now we can consider our like terms. Where do we have the like terms? We are supposed to collect your like terms. All right, so where are we having the like terms? We have got, all right, this part of a squared also can be affected with this part of a squared. So we are going to have 8a squared minus 5a squared. All right, we have got the part of ab and this part of ab. So we have got minus 26ab minus 3ab like this, plus this part. All right, it's just a single term that we do not have any like term. All right, we have got here, which is 15 b squared. So there is a like term there, 15b squared, right? So that is going to be plus 15b squared plus 36b squared, like that. All right, so we took the part of AB here, which is minus 26AB and minus 3AB. This is the one that we are seeing here, minus 26AB and minus 3AB. This is the one that we see here, minus 26AB minus 3AB. Then the part of A squared and A squared, we took here, this one, 8A squared minus 5A squared. All right, so this is 8A squared minus 5A squared. Then the part of negative 26AB minus 3AB, which is this one. Then the part of 15B squared and 36B squared, which is this one, right? So that is, we've got our like terms there. And we can now combine these terms together by simplifying 8 minus 5, which is going to give us 3. So that is going to be 3A squared minus 26 minus 9 minus 26 minus 3, which is minus 29. Or you can just use your calculator, like I said. Let us just see, minus 26 in this case. All right, minus 26 minus 3. All right, we are at this point here, minus 26 and minus 3. So just like this, but negative 29. So that is going to be negative 29AB. Right, we move on to the last part of A of B squared and B squared there. So it's 15 plus 36, right? So if we add 15 and 36 together, that is going to give us 51, all right? So this is going to be 51b squared. So we've got 51 b squared at the end, right? So this, we are not going to have anything, just gonna leave our answer as it is, just gonna leave our answer as it is, like this. So we have expanded everything that we had, collected our like terms. So as you can see at the end, we are having a trinomial expression at the end. All right, so just have to be careful on your simplification, expanding of your brackets properly, and also collecting of like terms. After that, you've expanded, make sure that you collect your like terms properly. All right, then we've got the E part here that we have. All right, so because of time, I think we're just gonna end here. Then that exercise, we are going to have it on a separate class in another class. All right, so let us just finish here. Find the product. We've got the product of these two. That is k squared plus 3/4 like this, all right, into the bracket of k minus a half. All right, so that is our question there. So we are asked to expand. So that is the part of what? Of E. So how can we expand? So just like what we've been talking about, guys, same scenario, the k is going to multiply everything. Let me just indicate it on top so that we do not have mix up. So the k multiplies here, the k also multiplies the part of what? Minus a half, this part of k squared. So if we multiply k squared and k, this is to the exponent of 1. So remember, if the bases are the same, you add the exponents 2 plus 1, which is 3. So it is going to be k to the exponent of 3. All right, we are done with this part. We move on to k squared and minus half. Minus half is just a constant, so it is going to multiply as minus half k to the exponent of 2. All right, minus half is just a constant, just like 2. Just like k squared times 2, it will be just 2k squared. So it's the same thing, minus half k squared. All right, which is the same scenario that we're going to have here. 3/4 is going to multiply here, and also is going to multiply here. All right, so this is just a 1 there. So it's 3/4 times 1k. So it's 3/4 times 1, which is 3/4. 3/4 k. Remember, if you multiply any number times 1, it remains as it is. So 3/4 times 1, which is just 3/4k. All right, we do the same thing, 3/4 times minus 1/2, which is the last term. All right, so on that part, not to have confusion, you can just use a calculator here, or you can just multiply the numerator to the numerator. Okay, I'm going to show you later on. So what I'm simply saying that you can just use a calculator. 3 over 4 times minus 1 over 2, that is 3 over 4 like this. Then we multiply negative 1 over 2. So that is negative 1 over 2 like this. So this is going to give us negative 3 over 8, right? So that will be negative 3 over 8. And this is just a constant that we are having. Remember, it's a constant to a constant. So like I said, you could have multiplied this direct if you want. 3 over 4 like this, multiplied to negative 1 over 2 like this. All right. What you're going to do is just multiply the numerator to the numerator, the 3, and the minus 1 together. So it is going to be 3 times minus 1, which is minus 3, over 4 times 2, which is going to give us 8. So that is the negative 3 over 8 that we see there. So you can also do that if you want. You can just use your calculator to simplify. So as we can see, here we do not have any like term. All right, there is k squared, there is k, here is k cubed. So we do not have any like term to consider here. So we are done. All right, we are done because we do not have any like term that we are going to consider. So like I said, just because of our time, guys, what we are going to do is to have an extended class that we're going to have. We are going to work with this as a separate class so that we just revise also along these questions that we have here so that we can just revise along. But as you can see, these questions are pretty clear. So I just want you to go through these questions. I'm not going to do all of these questions. I'm just going to have a recap on 1 or 2 questions, but I want you to do this exercise, work with these questions so that you can also point out where we have got a challenge. If there's a question on this exercise that you want me to work on that is still having a challenge, you can do that. So you can just point out the question so that we can work on those questions together, revise them together. But I want you to try these questions so that when we meet, maybe I could have done the question that you answered or the question that you have a challenge on. But like I said, I'm not going to do all of these questions. I'm just going to do touch-ups on some other questions so that you can understand. But the rest, like I mentioned, let us revise as much questions as we can.